Alright, in this video I want to give a brief overview of how I think of the connection between exponents, radicals, and logarithms. This is meant to be a high-level, quick video, so I'm going to avoid a lot of the details about each of the components, logarithms, radicals, and exponents, but just to give you a general overview. So we're going to use this expression to guide us along through understanding how these things are connected and what they're used for, basically. So we have 3 squared equals 9. I think if you've done basic algebra, this should not be a surprise to you. You should understand this here. Okay, let's get started. So let me choose this color here. Now let's say that we happen to have all 3 numbers in this expression here. So there aren't any questions we have. We have all the information we need to solve this equation. However, let's say for a moment that we do not have a part of this puzzle here, a piece of this puzzle. We don't have one of them. So we'll just make that x. So let's go ahead and say that we have 3. Change the color here. So we have 3, and we know that it's squared, and we know it's going to give us some number. We don't know x. How are we going to solve for this here? So really what we do is we use exponents here to solve for this, and this is fairly straightforward. This is 3 multiplied by itself 2 times, so 1, 2, and then the 2. The exponent here is 2, so we multiply the base number, by itself in this case. If it were 3, then we would, if the exponent were 3, then we would multiply it a 3rd time. If it were 4, we would add another one yet again, but we're just using this example, it's squared, so that's what it is. This is a quick reminder, this is also the same thing as addition. Multiplication is the same thing as addition in a sense, because if you have 3 groups of 3, is how you could possibly, one way of saying it. Here's one group of 3. Okay, here's your second group of 3, and here's your third group of 3, and that will give you 9. So we're using exponents here to rewrite multiplication, to go to addition, and give us the answer. So long story short though, we're using exponents here. Okay, so when we're solving for x, we have this, we're using the exponents here to solve for x. Alright, now let's go on to the next example here. Alright, let's say that we don't know what 3 is, so we'll put this in as an x. We know that it squared will give us 9. So what we're saying is some number x multiplied by itself is going to give us 9. And actually, this is what we use radicals for. When we're solving for, we don't know what 3 is, we just know that we know it's x, we know that it's to the 2nd power is going to give us this number here. We're going to use radicals for that. And let me just quickly remind you what a radical is. I'm sure when I write this example down, you may be reminded what I'm talking about when I say a radical. So here is the radical symbol. Then underneath we have our radicand, which in this case is 9, and we have our index here. Usually if it's a square root, it's not written, it's assumed, but we're going to just put that here for example purposes, and gives us x. And how we would say this here is that some number, so in other words, this is also the same as saying x multiplied by itself, because 2 times, we have 1, 2, we have 2 in the index, 2 up here, as the exponent. In a radical expression, it would be the index here, so it's 2. So this is the same as saying x multiplied by itself, because here's 1, here's 2, multiplied, by itself here, is going to give us 9. And what number multiplied by itself will give us 9? Well, we already know, this is just a really basic example, but it's 3. Because if you take 3 times 3, or 3 times up here, like we did up here, it will give us 9. So all this is saying, all radicals are saying, is some number x multiplied by itself going to give us 9. In other words, how do we get 9? By multiplying some number by itself. Okay. Now let's just go over this because I don't want to use blanket statement here. But let's say that we had 8. Okay, and we had this was the index for 3. All right. Well, in this case, again, look what we have here. We have a 3. And again, I don't want to get too in-depth in how these things work, but I just want to remind you that it changes. It's not by itself always. It depends on the index. So this right here would actually be, so this is the same as saying that, and it equals x, okay? We're trying to find out x. So the number x, okay, multiplied by, x times x times x will give us 8. Well, again, this is the same thing as saying x times x times x is going to give us 8. And I'm just going to give you the answer in this one, but it's 2. So in this case, it would be 2 times 2 times 2, because 2 times 2 is going to give you 4, and that times 2 is going to give you 8. So in this case, some number, in this case, we'd actually write it like this. X to the third power is going to give us 8, and that happens to be 2 to the third power is going to give us 8. But if we're solving for it and we don't know that it's 2, we'd say some number x, multiply, so x times x times x, so multiply by itself 3 times will give us 8. All right, let's clear this out of the way here, and let's go ahead and continue. So again, all radicals are saying, assuming the index is 2 here in this example, some number multiplied by itself is going to give us 9, going to give us this number here. Now, logically, the next step in the process would be what happens, let me pick my color here, okay, so I'll use red, or this color here, okay. Now the next step in the process, logically, like I was saying, would be if we know 3, and we're solving for the exponent, and so you don't even need to know what a logarithm is to know what purpose it serves. Well, a logarithm is basically solving for this. We know the base number, we know 3 to some power is going to give us 9, okay? And logarithms look like this. Possibly you may have seen this. The notation for me at first was a little scary, but it's log, okay? Then you have your base number, log base 3, and then you can put here of 9. Okay, so all that's saying is log base 3, this is our base number, is going to give us 9. So it's going to give us 9, all right? And this would equal, we know what it is. We know that it's 2, but so it equals 2, all right? And this is the logarithm right here. Also, you could say that it's the exponent, but anyways, and this is the base, this is our number here. So this is what a logarithm accomplishes. It says we know that we have 3, but we're missing the power. We don't know to which power we have to raise the base number to get our answer, and that is what a logarithm does. So this is similar. Let me see if I can draw this out visually here without confusing you. We know the number. We have 3, but we don't, and we have to multiply by itself. But we don't really know how many times we have to multiply by itself to give us 9. We don't know the number of times we have to multiply by itself to get our answer. So that's what a logarithm is solving, all right? That's what it's helping us solve. So it answers the question, how many times we have to multiply our base number to get our answer. So in this case, it gives us, we know because of this easy one up here, this easy example, that 3 times 3, so the answer is 2, the logarithm is 2, because the exponent is 2, is going to give us 9. 1, 2, okay? We didn't know up here, but we do know that it's 1 and we do know it's 2. So I hope that this was somewhat explanatory. I hope that it makes sense. Just to review very quickly, here we have the base number, we have the exponent, we use exponents to solve for x. This is just how I think about it. I know it could, not technically possibly correct, but this is just how I remember it easily and to get it straight in my head. So we use exponents here, okay? Now, if we're solving for this number here, if x happens to be the base number and we know which power it's raised to, okay, we know the exponent and we know what our number is, right here is what we would use radicals for, all right? Again, this is just a way that I tell myself this so it makes sense in my head and I can remember it. And then lastly, we have this instance here where we have the base number, we don't know how many times we have to multiply by itself to get our answer. We're trying to find the exponent, which is the logarithm, all right? That's when we use logarithms. So we have exponents, radicals, and logarithms. There's some really interesting connections also that exist between exponents and radicals, and same with logarithms too, but I will save that for another video. The main purpose of this video here was, again, just a general high-level understanding of these three things. Hopefully it wasn't too complicated. The main takeaway here is that if you have a to the b power equals c, you could just think of it like that, and depending on which one of these is missing, depending on which one of these items is missing, you use the two pieces of information that you do have to solve for the missing one, and depending on which one is missing, you'll either use exponents, radicals, or logarithms. All right, that's it.